In this question, we're asked to find the fundamental frequency of some signal x of t, which is the sum of two sine waves. So we've got sine 3 pi t and sine 4 pi t plus 7. And we're asked to find the fundamental frequency. So that really assumes that x of t is periodic. Now we need to check if it is indeed periodic. So we're adding two periodic components plus something which isn't periodic, a DC term. And we need to first check if it is periodic. So what's the period of our first component? So the period should be 2 pi over omega. So it's 2 pi over 3 pi, which is 2/3. And the period of the second sine wave is 2 pi over 4 pi, which is 1/2. So we've got these two periods, 1/3 and 1/2, and we need to first check if T1 to T2, that ratio, is it a rational number? Can we express T1 over T2 as a ratio of integers? So in this case, it's 2 over 3 divided by 1 over 2, and yes, that is a rational number. So yes, this is a periodic signal. So that's the first bit. We found that it is a periodic signal, so therefore it will have a fundamental frequency, and that fundamental frequency is going to be 1 over t. So the question now is, how do we find that t? How does t relate to T1 and T2? So you'll remember from our first lecture, we said that when you add two periodic waveforms, and if their periods have a rational ratio, then the period of the sum will be the lowest common multiple of T1 and T2. So T of x of t is the lowest common multiple of T1 and T2. So what we're trying to do is find the lowest common multiple of 2 over 3 and 1 over 2. So that isn't too difficult, is it? So we're finding the lowest common multiple of two fractions. It would have been easier if they were integers, but it's not too bad. We can rewrite 2/3 as 3/6. No, we can't, as 4/6. And we can rewrite half as 3/6. And now, because we have a common denominator, we can simply find the lowest common multiple of the numerator. So the lowest common multiple will be 3 times 4 over 6, which is 12 over 6, which is 2 seconds. So that's how you would find the lowest common multiple. You could do it the long way, but you'd be wasting a lot of time. So you could say that 4 over 6, 8 over 6, 12 over 6, 16 over 6, etc., and 3 over 6, 9 over 6, 12 over 6, 15 over 6, until you find a match. But that's not the best way to do it. I would do it this way. But in any case, once you've found the period, t, you can find your fundamental frequency simply by saying that f0 is 1 over t. So in this case, it's 1 over 2, which is 0.5 hertz.